Good afternoon to everyone. In today's class, we are going to see half wave rectifier. Okay. So first of all, we should know what is meant by rectifier. So rectifier is a device. Rectifier is a device which converts AC to DC. AC to DC. Kindly observe here after after rectification of your AC waveform, you can get the pulsating DC. You can get the pulsating DC. This pulsating DC will be converted into pure DC by using your filters. So for time being, just remember rectifier is a device which converts AC to DC. Okay. Here AC means it will be represented with sinusoidal waveform. It is represented with sinusoidal waveform. We know this sinusoidal waveform, that means the AC waveform will be represented in terms of cycles. So each cycle is composed with one positive half cycle as well as the one negative half cycle. So to represent this waveform, we given the equation with terms of Vm sin omega t, where Vm represents the magnitude and omega t represents the phase angle. So omega t minus phi. When that phase difference is equals to 0, it starts from 0 onwards. Okay, so it is angle. So here this is the magnitude, positive magnitude, and this will be your negative magnitude. Okay, so again once it reaches to the 0 crossover, again the cycle will be starts. Okay, so here in this cycle, that means in positive and negative half cycles, if only one half cycle is rectified, that means either positive or negative based upon your position of your diode, those cycles will be rectified. That rectifier is called as half wave rectifier. That means, in simple words, in AC waveform we are having positive and negative half cycles. The device which rectifies either positive or negative half cycles only, we call that one as half wave rectifier. That means the expected output, that means if I am considering only the positive half cycles will be rectified. If here I am considering only the positive half cycles are rectified. Okay, so kindly so that means in positive half cycle your device should be operated, that means, and in negative half cycle it should be not respond to your input, and similar to you, again once the cycle starts, again it should be act. That means here it should be respond in positive half cycle, and whereas in comes to your negative half cycle it should not respond. That means it should be non-conductive path there. Again for positive path it should be conductive. Okay, that means the device should have both the properties of conductivity as well as the insulation. So it should be an conductor as well as an insulator. So when you go through this, the property, the equipment or the device which have both properties of conductors as well as insulators, we call them as semiconductors. Okay, so here the well-known semiconductor for us is PN junction diode. We will check how we can get this output. Kindly observe we are not modifying the magnitudes. We are just rectifying instead of getting the positive and negative half cycles, we just rectifying it. Okay, so here I am taking an AC input. I am taking my AC input from the supply. I am taking the AC input from supply. So whatever the 240 or 220 volts or 230 volts, I am taking that supply, and that will be fed to the transformer. In order to reduce the voltage levels, because the semiconductor devices will be work only for the lower voltages. So it is an electronic device, so it will be goes for the lower voltages, that is less than 30 volts. So we are going to step down our voltage from 240 volts to 12 volts. 240 volts to 12 volts. Here the question is, where should I kept? This is the positive, this is the phase and this is the neutral. This is the phase and this is the neutral of your transformer. Where should I keep the diode? So I have the two positions. I will check for first position. I will go through my line diagram or whatever the current conducting path. Then we will come across with how this works or not. So first case, I am placing my diode at point at point A. Okay, at point A I am placing my diode. So across this thing I am placing the load. Now we will check what will be the current flow through the diode, current flow through the resistor. So when we go through the current flow through the resistor, automatically we come across with the voltage, because in resistor both voltage and current are in phase to each other. Okay, the entire circuit is grounded here. Okay, so forget about this position. That means this part we are just looking at concentrate about your secondary terminals. We are mainly concentrating about our transformer secondary terminals. Okay, so when I observe this terminal A, before that I just want to say one more point. This is my anode, positive, and this is my cathode, negative terminal. Kindly here I also am mentioning 2 points before that. Always currents flows from higher potential to lower potential. Currents flows from higher potential to lower potential. In your PN junction diode, current flows from anode to cathode. Current flows from anode to cathode. From cathode to anode, current does not flows. That means in one direction it will be conductor and another direction it will be insulator. Okay, so here now in this sinusoidal waveform, I am applying positive phase right now. That means what you are saying, whenever I apply positive peak to the potential A, then it becomes positive. So the terminal A is positive compared to potential B, which is 0 volts, because it is grounded right now. So it is 0 volts. Now this is higher potential and this potential is nothing but here the same current is flowing on. That means your cathode will be lesser potential. I am considering it as negative. Here your anode will be positive. So from higher potential to lower potential, the current will be flows. From higher potential to lower potential, current will be flows. That means your diode is in on condition. Your diode is in on condition. On condition means it is allowing. So whatever the current is coming at the anode terminal, it is allowing through it. Then that means it is acts like a short circuit path. That means we are representing the diode like this. That means whatever the current comes, it just simply allowing. So at this moment we will check. So this is secondary of your transformer. The diode is short circuited, and this is your load. So whatever the current comes to your secondary terminal, is simply going through your resistor without any deviation and makes it as closed path. So when I apply my positive half cycle, whenever I apply the positive half cycle, the current is appears. Because of that current there will be an voltage drop. This voltage drop was also in phase of my current. So whatever the applied voltage, the same voltage will be appears across my appears across my load. This is the load voltage, and this is my input voltage. Okay, so now it is fine. I just came to know during the positive half cycle, this becomes the positive and this becomes the negative, so it will be short circuited. So whatever the current, it just flows. So fine, very good. What happens if I apply negative? So we will check. I am need not drawing all the things. I just simply okay. So now I am applying the negative potential here. So this is A, this is B terminal. Now your anode becomes negative. Your cathode is still, it is grounded. That means it is 0. So 0 potential. That means now which terminal is higher? Cathode. Cathode is at 0 volts. And your anode is in negative volts. That means from anode to cathode, current will be flows? No, because this is the lower potential. Cathode is at higher potential, 0 volts. It is 0, higher potential. From cathode to anode, current should be flow, but current never flows from cathode to anode. It should flows only from anode to cathode. That means at this condition, no current is flowing through your diode. So at this moment we will check. Current doesn't flow. So at this condition, diode is in off. So when you switch off your fan, is it rotating? No, because no current is flowing to it, because if it is an open circuit. So there is any break in your path, we can't move. Likewise, the current will just come and wait for until it close, it won't go. So we will check how the line path will be there. So up to here it will be there, and this one. So when I apply, the current is just waiting here and never goes to the load. So there is no current. When there is no current, there is no voltage drop, because V equals to IR. So there is no voltage drop. So there is no voltage drop. V naught equals to 0. So simply it is 0. And up to the next positive path, next positive half cycle comes into the picture. So this is the whatever the operation of your half wave rectifier, and this will be the how it is working. Okay, I hope it will be understandable to you. Thank you.